All right, welcome to the exciting world of I Can Do Physics. We are going to be talking about how to translate a velocity time diagram. So I'm going to just make some simple notes here. So one thing we want to always remember is that the area is equal to our displacement. So when I say area, I always say I want to talk about the area between, let's get a good color here, I like blue. We're talking about the area between the actual velocities. So this is a velocity of 4, and this is the area that I'm talking about. It's between the velocity line and 0. So for the first part, if you look at the area, you've got a grand total of 4 here, and then you've got a grand total of 4. Alright, so if you look at that, that tells us the actual total is 16 meters for that first 4 seconds. So this object traveled 16 meters in the first 4 seconds. But then, if we want to say, well, how far did it go the next time? Well, if we look here, it was traveling -8. That should be a negative sign. Let's get a negative sign on that so we're not confused. Yeah, that should be a -8. So it traveled at -8 for a grand total of 3 seconds. So if we just shade that in, then we're going to -8 times 3 gives us, dun dun dun, -24 meters. So if we want to know what our total displacement was, this would be equal to 16 meters minus 24 meters. And again, it's minus because this is a negative displacement. So that gives us a grand total of -8 meters is our displacement. Now that's for the whole trip. So if you want to do part of the trips, you could cut it up into pieces, but either way you can still figure out area. All right? Now, we want to then take that and we want to actually make a position time graph from that. So here I got a position time graph, and so I'm just going to be transcribing things. Most important thing about position time graph is that in order to make it, you have to know where you started. Velocity time graphs never tell you position. Alright? They only tell you displacement, how your position has changed. So to make this graph, I have to first say that my initial position, let's say, was 4 meters. Alright? Alright, so let's see. Let's just go by 4s. So 4, 8, 12, 16, 20. Alright, and then that's 0. And that means that this down here is -4, -8. So I started at 4, so I'm going to put a big old dot right here. All right, giant dot right there. And let's change our color. I like different colors. Colors are fun. Yay. Yay, red. Okay, let's go with that. All right, now, if we look back up here, we said after the first 4 seconds, our displacement was 16 meters. So I'm going to go 4 seconds later, so 1, 2, 3, 4, and it was 16. So I gained 16. So 4 plus 16 is, yep, you guessed it, 20. All right, so we put a little dot there. Now, since we had a nice positive constant velocity, then I have to represent that on my position time graph. So a nice positive constant velocity would be a nice straight line because it only has one slope, one velocity. Now I got to deal with the second part. Now the second part here lasted only 3 seconds, and I lost a grand total of 24 meters in that. So 20 minus 24 is -4, and that was after 3 seconds. So I'm going to put a dot right down here because at this time I'm at 4, and I should draw a line there. And that's how I create my position time graph. And I can check myself because theoretically, if I did this correctly, this should have a slope, all right, which is my velocity, of -8. And if I did this first one correctly up here, it should have a slope of 4. So velocity equals 4 meters per second. So I could double check myself, and since we're doing stuff, we might as well double check ourselves. So let's see if I just do this and this, let's see how well I did. So from 4 to 12, so that's 16 meters, and then this is over 4 seconds. So 16 divided by 4 is 4. All right, that's looking good. And then over here, I'm going to do this one, and this is 3 seconds, and this is 20 to negative 24, so that's negative 24. And so negative 24 meters divided by 3 seconds is 8. So you can always check to make sure you did it right. And that's how you translate a velocity time graph. Again, you're looking at areas. They only tell you displacements. And you can take that knowledge and you can make a position time graph. So I hope you find that helpful. Join us next week when we try and do something else that's probably related to physics.